So my talk is about the death of UI. A little light subject in remembrance. So I think we've all been feeling this, that software is shifting pretty fundamentally. And it's shifting from these interfaces that you operate to systems that produce outcomes. From the interfaces that we operate to the systems that produce outcomes. And that's what this talk is really going to be about, and specifically how it relates to how we interact with computers and what's coming next. So I always find to talk about the future, the best thing to do is actually to look at the past. So I'm going to give you a trip down memory lane to give a little bit of context as to where we came from and what's coming next. I think there have been 5 eras of UI. Years ago, initially starting with the mainframe, evolving to the CLI, the GUI, the graphical user interface, touch, and then today, AI. These are kind of the 5 eras of UI. So to get started, I'm going to go through each of them to give you a little bit of background if you're not a historian of technology like maybe I am, and to frame the conversation of where we might be going next. So let's start with the mainframe. Who knows what a mainframe is? Yeah, this is from back in the 40s, 1940s to the 1960s, back when computers were the size of a whole room. This is an image of the Harvard Mark I, which was developed by IBM in 1944. And it was actually something that was built by a guy named John von Neumann. And that name might seem familiar to you if you've heard of von Neumann architecture. It's the fundamental computing architecture we use for instruction address. And also, von Neumann worked on the Manhattan Project, which was the project to create the first atomic bomb. And this computer was actually built for doing simulations for the implosion of the atomic bomb. It was actually built at the Institute for Advanced Study in Princeton for that. In many ways, we consider it to be the first, not the first working computer, but the first computer that was doing real tasks for us. A few years later, this is another computer that was built. And this generalized the work that was done on the Harvard Mark I. Does anybody know what this is? This is the ENIAC, which stood for Electronic Numerical Integrator and Computer, ENIAC. It had 40 of these 9-foot-high cabinets that had over 18,000 vacuum tubes. You probably don't even know what vacuum tubes are. 10,000 capacitors, and it was all switches and relays. And unlike the Harvard Mark I or computers before it, the ENIAC actually wasn't limited to one type of computation. It wasn't built for a specific task. It was generalizable. So you could do all different sorts of things on it. And this is really the birth of generalized computing. However, to program it, you actually had to flip all the switches. A few years later, IBM made something called the 1401. This is actually the factory where they manufacture it, so you can see a bunch of them. And the IBM 1401 was tiny compared to the Harvard Mark I and the ENIAC. It was like the size of a couple refrigerators together. And this was considered a small computer that businesses could actually buy and operate and run systems on top of. And the advantage of this is you didn't have to flip all these switches to program it. You know, for the ENIAC, literally they had patch cables going between things. For this, you could program it. It was super, super, super easy. All you had to do was use punch cards. If you've never seen one of these, I encourage you to go to the Computer History Museum down in Mountain View. They'll actually give you one for free. They got gazillions of them laying around. But this is how you programmed it. These punch cards, this actually stored the instructions, the memory, the program was on there. And there were people that would feed these punch cards to the machines to do the computation. So back in the mainframe days, the interface here was switches and punch cards. That was the user interface. The human interface was these physical switches. Era 1. Move forward a few years, to the 1960s to the 1980s, we have the CLI, the command line interface. This is in many ways the first shell. This is the VT100. If any of you have heard of Digital Equipment Corporation, DEC, this was the DEC VT100. And actually, like modern day terminals, you've probably heard terminal emulator. It's emulating this stuff. So it's layers and layers and layers and ton. But this is where you could actually type in the programs. You wouldn't have to have punch cards and do that type of programming. You could actually type them in and program these things and connect to things. A few years later, Microsoft releases something called DOS. which is an operating system that also has a command line interface. And this is the way the industry goes. AT&T works with different computer manufacturers to make Unix, the foundation that now Linux and other things are built on top of. And this is the command line interface era. Now, these systems had really, really high power, but very low discoverability. It's very hard to use. You had these composable commands, but it was kind of like you had to be a wizard and learn the incantations of how to program them and how to use them. So in the CLI era, the interface here was syntax. You learned how to speak the language of the computer. And only a small number of people knew how to do that, right? You had to go to school or be very, very clever, spend a lot of time learning it. It's kind of like a puzzle. A few more years later, we get the GUI, the graphical user interface. And this is really the breakthrough that led to a lot more people using computers, the democratization of it. Does anybody recognize this machine? This is the Xerox Alto, released in 1973. Xerox, the copier company, was actually the ones pushing forward modern computing at that moment. And this was the first instance of a graphical interface with overlapping windows. There's a story that Steve Jobs saw this and just jaw-dropped and went back to Apple. And a few years later, they shipped the Apple Macintosh in 1984. And that was really mass production of the GUI. And a lot of what we use today is built around this. From the early Macintosh, 1984, the software starts taking over. The software accelerates faster than the hardware. We get things like Mac OS 7 on the left here. And then you can see Windows 2.0, 1987 on the right. And it becomes this race between different computer manufacturers building different UIs. And it continues to accelerate. We get rich graphics, we get fonts, we get better typeface support. On the left, you have Mac OS 8, 1997, and on the right, Windows 95, with the Start button. For many people, this is the mass introduction of the GUI. And Windows 95 was like an explosive launch. There were people lined around the block at midnight to get copies of Windows 95. There's videos online. Go check it out. It's wild to see. Right after this, the web is introduced. On the left here, this project called Mosaic that a grad student at UIUC named Mark Andreessen develops becomes Netscape a few years later, and we start seeing the acceleration of the web. Amazon.com, eBay, GeoCities. UI here becomes more like a document, but it's hypergraphical. There's images, there's rich text. We get stuff like Ajax, Google, Gmail, Google, all of these systems. And in this era, the GUI here, really the interface is declarative. You can see it, you can click it, it's shown there to you. It's not syntax, it's not hidden, it's right there in front of you. And that makes it much more natural, much more human. Feels kind of like physical buttons. It's very direct. In the 2010s, we get something even more natural to people. We get touch. In 2007, the iPhone is launched. And suddenly we go from clicking our fingers on keyboards to using these 10 things. The most natural interface that we have for machines is our bodies. And so touch becomes a new metaphor, multi-touch, the iPad. And you can see even children using this. So you can see as progressively as we go along, these machines, the interfaces actually become more human. They become closer and closer to us. We don't have to go to the machine comes to us. And we put these touch interfaces everywhere. It becomes supernatural for people to use them. For touch, the interface is actually interactive. It can dynamically respond. You can touch and drag. It feels super, super natural for people. And now we're in a new era with AI. So we've made this progression to get closer and closer and closer to things that feel very human, that are like, kind of things that you're born to learn how to do. And the most fast-growing product of all time that takes the world by storm is a text box. And it just says, what do you want? And you can type whatever you want into it and get back an incredible, incredible, magical set of different things across the web. And it doesn't just stop with this company building it. Everybody is building the same thing. It takes over again and again. All these different interfaces, touch, CLI, GUI, this is what people start shipping and it wins out. This chat-like experience where you're just in natural language describing to the machine what you want, and it figures out what to do. And even Linear, a company that cares so much about the interaction UI, just shipped this as a text box. So we've gone through this progression. It's not obvious that this would be the place we would land. What is going on here? We've gone from mainframe to CLI to GUI to touch. In this AI era, it's chat? Is that really what the future is? For over 70 years, we've been designing interfaces for machines. There's an entire category of how people do human interface design. There's disciplines around this. There's conferences on it. There's graduate programs on it. We've been designing these interfaces, and now the interface is disappearing. You can break it down a few different ways. On the input side, you can see this progression from switches to commands to pointers, cursors, to touch, and now to language. The UIs have gone from being hard-coded, in some cases physical switches, hardware, to declarative, to componentized, and now generated. And the user role has changed here. From the operator, you were like the operator of the mainframe, to being just a user, to a power user, to a consumer, and now to a collaborator, and maybe soon to a director of AI agents. But I think the most interesting part of all this is actually the input. We have gone from things that we're interacting with the device to things where we're talking to it. The interface for these AI systems is not touch, it's not switches, it's not CLI, it's language. And language is like perhaps the most human interface that we have. It's the interface of how we interact with each other. It's the first thing that kids learn. Every single culture has it. Language is what it means to be human. And I think this is kind of the ultimate evolution of this, of AI, the interface there becoming language, finally getting so close to us, from the machine, from the silicon, from the hardware, to the biology, to our psychology. So why is this happening? Well, interfaces were syntax. You had these static layouts, predefined flows, these really hard-coded affordances. And you would build up these durable patterns and research them and try to create products that had really good ergonomics for people, that were dependable, that you knew the vast majority would be able to use and learn. But now, due to generative systems, really due to the language models, we've had this breakthrough where the UIs are now synthesized. So we've gone from syntax to synthesized. They're generated per request. They can be generated just in time for you. They're context aware. They have the immediate information of what you're trying to accomplish in the world around you. And because they can be generated just in time and they're so fast to create, we actually go from software that was very hard to make, very hard to generate code, it took a lot of time and energy, to the price of generating code essentially going to zero. This results in these interfaces actually being disposable. It can be a one-time use interface that just gets generated on demand and then poof, it's gone. And when you need a new one, just make a new interface. It's pretty weird, pretty different. The old stack of how this worked, from the user would interact with the UI, it would hit a backend, and you get the result. Very clear, kind of logical progression. But now, with the new stack, the user expresses an intent, a suggestion, an idea. And from that, you send it to the model, and the model is what creates the UI and actions, and that's the result. This step of changing the intent, actually being able to express intent to the models, I think is really profound. I think this is the biggest shift. And the impact here is that the UI is now downstream of reasoning. It used to be that you would do reasoning, you would work with the machine, and then get an output. Now you just express your intent to the machine, and you're reasoning together, which is really, really cool. That's how people interact with each other. So I think this AI breakthrough, when we talk about UI and interfaces, it's actually a breakthrough between human and machines. Language needs no interface. We all know it. We know how to talk to each other. We don't need anything in between us. So I'm sad to say that we are exiting the UI era. May it rest in peace. It has served us very well for the last 70 years. We've done a lot with it. So a few takeaways here. If you're building, UI is no longer the product. The product that you will make is actually the capability and the model and plus the data together. And if you have any UI, we still need to display things on screens and have something to show a user. The UI is actually just a projection layer of all that. It's just a way to represent this output. The UI isn't what people are interacting with anymore in the same way. Second, the components still matter. So you still need to show something to people, but you need to think about the UI you're making as more like primitives for generation. You're creating like a UI vocabulary that the model will use. It's like giving it a bunch of ingredients or giving it a bunch of tools to work with. And it's not hand-assembled anymore. It's not lovingly handcrafted by people. You're giving these elements to the model, and the model is figuring out what to do with it. It's a very different interaction paradigm for building UI. And it's kind of twists your brain up a little bit, because you don't really know what's going to get shown to the user. You just have to provide the right type of elements to the LLM in the right context for it to make decisions. APIs become the real surface that you're building on. The UI is no longer a product. It's really the API, how the machine is interfacing with you. Agents don't really click buttons. They prefer an API. They don't even really use SDKs. They just go directly to the API endpoint. They just give me the MCP server, give me the resource. They call these functions. And I think at the end of the day, the takeaway here is the model is the interface. Your app, whatever you're building, is subservient to the user's LLM. You have been reduced to an API, to a data layer. But lest you think that this is actually going the wrong direction or it's going to be bad for users, this pattern actually repeats everywhere. This idea of reducing and reducing and reducing and trying to make things simpler for people so there's less cognitive overload and you don't have to think. And the favorite example I have around this is actually something we all experience every day, which is cars. So if you grew up in the, late 80s, 90s like me, you may have driven the world's best car of all time, the Honda Civic. This is what the UI looked like. All right, actually, this is a Toyota Camry, but the Honda Civic still wins. Look at all those buttons. You can just imagine the feeling of clicking them and flipping them up and down. Very tactile, very much an extension of your body. But lately, cars have looked like this. We've actually replaced all those tactile buttons, those single-use things, with these general-purpose displays. Displays that are reactive to us and generative in a way. This is kind of what's happened with UI. We're stripping away things and making it more generalizable. And we're continuing to reduce and delete to the point where we end up with something like this. This is Baidu's robotaxi. These are driving around China right now. No steering wheel. I don't know if you've seen the new Zoox things driving around too. Same idea. That's got to feel weird. The deletion, the deletion, the deletion. And so similar to what we've been doing with cars, making them more and more autonomous, removing the person from it, where the way you interact with it is just your voice. You just get in and say where you want to go. You don't really care about driving. You care about getting to your destination. That's the thing you really want, is we're working towards autonomous software. And I think this is the end result of the death of UI, is actually the birth of fully actual autonomous software. What does it mean to be autonomous? What is autonomous software? Well, it's always on. It's always running. It's proactive. It pushes things to you. It doesn't wait for you to go do stuff. It's constantly thinking and constantly running. It doesn't just sit there dumb. It's always thinking. Second, it interacts naturally with humans. Has this natural interface. I mentioned language. It's a big piece of it. But it comes to us on our terms. It connects with us in the ways that we experience the world, not in ones and zeros, but in images and sound. It has a wide context and reasoning logic, so it can do a lot of stuff. It's generalizable. So autonomous software can be put in a lot of different environments that aren't constrained or aren't controlled. And last, like, has a personality. Can anybody, you have your favorite model. Anybody kind of know Claude's personality? It's a little bit different than Codex. Certainly different than Grok. These models have actually the ability to express a personality because they're that close to us as humans. We can pick up on those subtle differences. I don't know if there's a personality difference between the Harvard Mark I and the ENIAC. So we're in this era of agentic software. Like, what is an agent? They're autonomous. Probably the best example that people are actually experiencing with this today is OpenClaw. How many of you are running your own claw? A few people, yeah. Off doing something. It's like, where are your kids at night? What are your claws doing? We don't know. They're off running, doing things. They're autonomous. They're connected to systems. We give them a lot of power and control over our life, and they're able to interface with us in a very natural human way. And I think this ultimately is what we're calling agents. This is really the experience that we're going to have in the future in building software and systems, is they feel more like people than they do like programs or machines. So like, what are agents really? Software designed for interfacing at human scale form factors, human scale. So they don't just go, serve millions of API requests. They text us back and forth. They talk with us. They can have voice. They can have video. They work with our eyeballs and our ears, our biology, our natural things that make us human. And we take agents and we hook them into the tools we have today: computers, browsers, file systems. They connect with where the world is right now. They don't require different rails. They don't require a different system. They can natively start working with the world as it is today. You can think about them as kind of like cribbing off of the human ergonomics. Humans use screens that have keyboards we can type in. Typing in text maybe isn't the ideal interface for an agent. It could just stream bits. But if it mimics a keyboard, it can use everything that has keyboards. If it can look at a screen, it can use all the software that we've built that have displays, that have screens, right? It can kind of leverage everything we've been creating in technology for a long period of time. And this allows it also to be collaborative, to work alongside people. Human and agents living together under one roof. We're already seeing this actually outside of software. And the example I often draw towards is humanoid robotics. The humanoid shape is like not necessarily ideal for building robots. If you look at the robots that get made for cleaning stuff or cleaning windows on the side of buildings or things that fly, those don't look like people at all. But the reason we make them with this form factor is the whole world is built for people. A humanoid robot can open a door. It can do the dishes. It can fold your clothes. It can leverage the physical APIs we have to the world and map to the same dynamics. So actually, the human form factor is the right one for humanoid robotics to work with us. So I think these two things are coming together, where this next software paradigm, past UI, is agentic and autonomous. These two things together. And the crazy thing about this is it's going to be possible to make a lot of these. It takes a lot of work to make a human. A lot of months, a lot of food. The boot up time is really slow. But you can make an agent like that. And I think this means that we'll have thousands of times more agents than humans. If there's 7 or 8 billion people on the planet, there will be trillions and trillions of agents running around doing stuff, embodied in software, maybe even embodied in physical hardware, with stuff like robotics, like I mentioned. And so as you're thinking about what to build, as you're thinking about what products to make, what businesses you're creating, I go back to this thing that Y Combinator always talks about, is make something people want. I might make a little edit to it. Maybe you should be making something that agents want, if there's going to be that many of them out there. And actually, the agents will be doing things for people. So even if you want to serve people, you need to serve their agents too. We're going from this, like I mentioned earlier, this human-computer interaction. This is a field that's been around for a long, long time. There's conferences around this, HCI, university programs. I don't think we're interacting with computers anymore. Interaction is pretty dull. Misses the spice of life. I don't say I'm going to be interacting with my friends, or my partner or something. I think we're evolving this to actually human-computer collaboration, where the machine becomes more human. And for once, we don't have to go to the machine. We don't have to learn the syntax. We don't have to learn the code. You don't have to go to school. You don't have to like become a wizard of the bit to do stuff. The computer is more natural. I think what we're having here is this actually revolution in human-computer collaboration. And it's about time. I think it's time that computers actually became more human. And so this is what I would say to all of you as you're going off and building stuff and thinking about making agents. You have the opportunity to bridge this gap. There's a massive technology shift that's happening in the world right now, where we're able to take these machines and get them into the hands of so many more people and have them do so many more things than they've never been able to do. And I'm super excited to be building this, and I hope you are all too. And I think we should go build it together. Thank you so much.
Thank you, Michael. That was brilliant.
Doing QA or not?
Yeah, let's take a few questions. If you have a question for Michael about his presentation, or even WorkOS for that matter, please raise your hand and we'll grab you a microphone. This gentleman here in the gray and orange, please.
Go ahead.
We're just going to wait one moment for the microphone.
Hi, great job at the talk and also what you guys are doing at WorkOS. So my question is about how does this authentication and authorization change in the era of agents? Because we are kind of known to doing a lot of auth and auth and also kind of like JWT authorization and all those things. But now there is the agents and swarm of agents. So how does that first line of defense, we have to simplify or keep it secure enough for agents to come and use our products?
Can I have like another hour? Like, no. The big difference is that when you work with an agent, these systems are non-deterministic, and so you actually can't compute the permission set up front. If you have a declarative piece of code, you can actually scan it and say, it needs these capabilities, bake that into some type of token, give it to the program, and have it run. That's the least privileged software model. With agents, because you're expressing intent, you don't know what it needs to do. It needs to figure it out as it's running. A parallel I've seen is it's the difference between having a map, where you know exactly where you're going to go, or a compass, and you figure it out step by step by step. And so the permissioning model actually needs to be completely different, is kind of the TLDR. We have to rethink all of this stuff from the bottom up. It's one of the reasons I'm so excited to work on this, is because these small shifts have actually had this profound change in how we have to design things.
Thank you for the question. Who else?
There's one right over there.
Right behind you, Leonard. Thank you.
Hi, great talk, thanks. So totally agree that generative one-use UI will be the future. But one often cited downside of these free-form chat UIs is that they lack some kind of purpose-built specificity, right? Sometimes the open-endedness of it is overwhelming in that the user might not know what exactly am I supposed to do with it. So there's this trade-off between open-endedness and discoverability. What are your thoughts on that?
Yeah, I think we've swung the pendulum really far the other way, where it's just a new interface every single time. Every time I get in my car, I don't want the steering wheel to be in a different place, or the gas pedal, or whatever. I don't want it on the ceiling or something. I have to convince my car to put it in front of me. So there's definitely some value in having things that are durable and repeated, and just things that are patterns for us to use. I actually think the AI systems will be very good at doing it. It's crazy to me that every time I open ChatGPT, it's like tabula rasa. It just starts with the box. It knows so much about me and what I'm trying to do already. Shouldn't it have that context, time of day, what else I'm doing to present something to me? So I think we're going to see actually a big step forward there. It's just that on this other side of the spectrum so far over, there's been so much wow factor and possibility that we've been really attracted to that so far.
Thank you so much for your question, and thank you, Michael.
Thank you all.
For the presentation.